So we have already looked at gram to mole and mole to gram conversions. I want you to take that and just set it aside for a moment and not think about how you did those. I'm going to teach you something different today. We're going to use the same process, meaning we're still going to be using factor label, dimensional analysis, long line, short line to solve the problem, but we're going to be pulling a different tool out of our toolbox today. So if you're watching this video, you are probably already familiar with what a mole is. Numerically, that's 6.02 times 10 to the 23rd. That is an enormous number. I'll be doing another tutorial just about the mole at some point, but that's a lot. It's 6.602 and add 21 zeros to that. So it's a really big number, and it's really only useful for counting very tiny things. So we use it to count atoms and molecules. And today we're going to look at some atom-mole conversions. How do you get from one to the other? And we're going to start with the mole and see how can you figure out how many atoms are in a mole. And you have to know the numerical value of the mole, which is 6.02 times 10 to the 23rd, and that's just like a dozen. It's just bigger. A dozen, if you hear that, everybody knows it's 12. And think about it this way. If you had 24 donuts, everybody could tell you very quickly that's 2 dozen donuts. If you had 36 cookies, everybody knows that is 3 dozen cookies. A mole is the exact same type of math that I just did. It's just with a bigger number. And once I go through these examples, that should be really clear. So we're just going to start with the first one. How many atoms are in 28 moles of carbon? So once again, we always write down the given. So our given in this case is 28.0 moles of carbon. We're going to draw our long line and our short line. Now, what we're going to ask ourselves is this. Do I know a way to get from mole to atom? Again, what is that toggle button? What tool do I have in my toolbox to do that? And in this case, you're going to use the ratio 6.02 times 10 to the 23rd atoms per mole. Now, if you'll remember from the previous lessons, whatever unit is on the top always goes on the bottom in the next step. And so we know mole is going to be on the bottom. Once again, mole is all by itself. That's going to make your work really easy. And we know there are 6.02 times 10 to the 23rd atoms, in this case of carbon, per mole. Mole is on the bottom, simply so it cancels with the mole on the top in the previous step. We are now ready to do our calculation, and if you'll remember with dimensional analysis, you multiply everything on the top together, divide it by everything on the bottom that has been multiplied together. In this case, the bottom is just going to be a 1. So when I multiply 28 by 6.02 times 10 to the 23rd, I'm going to get 1.69, and we're expecting a really big number here, times 10 to the 25th atoms. And you know it's more than 1. We'll drop the S just for a little bit of an abbreviation of carbon. If you have trouble putting this exponent into your calculator, remember you're using the exponential button to take the place of the times 10. You're not going to touch the times. You're not going to touch the number 10. So when you put it in your calculator, real briefly, I'll go over that because I know a lot of kids struggle with this. If I'm putting in 6.02 times 10 to the 23rd, it's going to be 6.02. My exponent is a second function, so I just train myself to say times 10. That little E pops up, 23rd. That's how I put it in. Different calculators may display that a little bit differently. If you've got a question, you can just drop it in the comments, and I'll be sure to address it. All right, let's look at number 2. How many atoms are in 15 moles of potassium? Write down the given first. 15.0 moles of potassium. Draw your long line and your short line. We know that there are 6.02 times 10 to the 23rd atoms of potassium in 1 mole. We already know mole is going to go on the bottom so that they cancel. By default, that leaves the 6.02 times 10 to the 23rd atoms, and potassium's just labeling what it is on top. Moles cancel, and we are ready to multiply across the top. So 15 times 6.02 times 10 to the 23rd, we punch that in, and we're getting 9.03 times 10 to the 24th atoms of potassium. Now, I would encourage you to actually follow along with these with a calculator and make sure that you're putting that exponent in correctly. That's where I see a lot of mistakes as a teacher with beginning chemistry students. It's an easy fix. You just have to know how your particular calculator works. Remember, the calculator's not always thinking like you are. It only knows what you're telling it. So let's take a look at number 3, last one. How many atoms are in 50 moles of magnesium? So we're going to write down the given 50.0 moles of magnesium. Long line, short line. We know that there are 6.02 times 10 to the 23rd atoms of magnesium, keeping everything labeled per mole. Once again, moles on the bottom because we want it to cancel out. We're ready to multiply across the top, and if you multiply 50 by 6.02 times 10 to the 23rd, you are going to get 3.01 times 10 to the 25th, I'm running out of room here, atoms of magnesium. 3.01 times 10 to the 25th atoms of magnesium. Now, a couple things I want to point out since we have done 3 examples. You will notice that aside from the givens obviously being different, the rest of the work is exactly the same. That's because when it comes to a conversion involving atoms to mole, it doesn't matter so much what it is because there's 6.02 times 10 to the 23rd, anything's in a mole. There are 6.02 times 10 to the 23rd books in a mole of books. There are 6.02 times 10 to the 23rd anythings and an anything. It didn't matter. You'll notice we didn't use mass in these like we did in the previous lessons. That's because we only use the mass from the periodic table if grams are involved. We're actually going to put all these lessons together in another one soon, and you'll have everything in one problem. But if you are dealing just with mole to atom, the only thing you're going to use is Avogadro's number, that 6.02 times 10 to the 23rd. I'll give you one more example just for reference. If I have 2 dozen cookies, that is 24 cookies. If I have 2 dozen eggs, that is 24 eggs. If I have 2 dozen people, that is 24 people because I multiplied all of those 2 dozens by 12 because there are 12 in a dozen. That is the exact same concept you're applying here, only a mole is much bigger than a dozen. The next tutorial is going to take you the other way, and those of you who've been following along probably know exactly what that one's going to look like. That will be atom to mole, and that will be following very shortly after this one, and then we're going to put it all together and probably go back and summarize everything perhaps in one more tutorial.